Hi, I'm Sean Anderson, Field CTO at Nearform and inventor of the Swift method for system modernization. I'm going to give you a short overview today of how we use Swift to get the most value out of your complex systems using modern technology and processes. What is a modern system and how do I get there? How can I take advantage of the benefits of modern technology, especially in cases where I have something that's been around for 20 years? I have legacy systems that are decidedly not cloud compatible or not even organized in such a way that I could take advantage of some of the other modern techniques and architectures. So, what we've discovered over years of fine tuning this methodology is understanding basically how the system wants to behave is the key. And what I mean by that is simply understanding how does the software in general, from a top down perspective, want to work to best support the needs of the business. What we found is the technology often isn't the problem or the barrier to having a modern system. It's a combination of the technology, the communication paths, maybe even lack of understanding of what the business actually does and how the software can be organized and made more effective to achieve the goals of that business. One of the first things that we need is really an understanding, kind of a situational awareness of the business. What not from a software perspective, but what does the business do? Understanding kind of pains and behaviors and forming a ubiquitous language. So when we're talking and saying words like customer, everybody from a technical perspective and non-technical all says the same thing. They mean the same words. They understand the same acronyms. And we use event storming to really get to the bottom of that. And that's all we're using it for at this point. And event storming will give us some of that information. We'll have a high-level view, and we'll probably have enough information to start thinking about, hey, there's domains or core capabilities that seem to be forming here. And we'll talk in more detail about each of these steps. But once we have those service candidates, those kind of core capabilities, that lets us go to the next step, which is where we start thinking about things like, okay, well, we have use cases or we have thin slices of functionality. As we're walking through the capabilities, here's how a user might want to do something, or here's what happens when an order is created. Those thin slices, those different types of functionality, whether they're happy or sad, positive cases or negative cases, are what we're going to use to start modeling our system before we build it. And I'll be showing you the details of the next step, which is Boris, which is really modeling, creating an engineering model of how the system really wants to behave. This is a way of de-risking the application, de-risking your development effort, because we're able to throw rocks at it, test, make sure that all of the happy path cases will work with our new system, the negative cases, and also the situations where we're trying to migrate or slowly strangle off functionality from an existing system. By modeling this first over the course of a day or two, it saves us a tremendous amount of time and effort in building software first and then hoping that it works. And then, of course, in the process of modeling our system and really getting a good feel for how things should work, we're generating a lot of information, and we capture that information in a shorthand form called Snappy. And what this is doing is giving us all of the information we need about how the system wants to behave, and that will give us the ability to go to the next step, which is applying patterns. The patterns really are saying, hey, we have a notional direction. We know kind of that North Star guiding principle, or we know about where we want to go, but we don't necessarily know how to get there. So kind of like a Google Maps navigating from point A to point B, we apply patterns or look for repeating patterns or use our experience coupled with your experience to figure out the best way to get from point A to point B. And then finally, once you have those patterns, you have a model, you feel pretty good about, yeah, I think this is the way the system wants to behave, and I think we have a good handle on how to get from point A to point B, then the process of creating a backlog of work or understanding and prioritizing how to start moving forward is the last step before we start actually doing software work and building our system. What we're doing with Swift is really we're effectively and efficiently gathering data, we're modeling a solution, creating a notional architecture, and that model is helping us de-risk and gain confidence moving forward. And then we're doing it and supporting it and evolving it. So the process is really iterative. We're going to get information, get enough to get moving, and start moving forward with confidence. Let's take a look at our first process. And again, we're looking at an iterative kind of drill down process. We use event storming to get that ubiquitous language and understand why we're doing things, a little bit about the lay of the land. And our participants in this particular case are a combination of business folks, technical folks, kind of everybody. And really what we're looking for is not how the system behaves today, but how does it want to behave? And we use the idea of business events to get this. And a business event is really just something that is like, customer updated or something happened. And the whole team in this at this particular point is putting business events in the system. We're really talking through here's what happens today from a business perspective. Here's kind of in a time series way, here's how they clump together. Here's the happy paths, the bad cases, pain points, things like that. So what this is doing is getting everybody speaking the same language, and more importantly, opening that communication path between the business and the technical folks, because after all, just understanding how things want to work from a business perspective will drive out good software. As we're doing event storming, we're starting to see clumps forming. These clumps of common business events are really showing us that there are business capabilities, something that is common. There's good things that are happening, there's bad things that are happening, there's combinations of functionality, and we start to think about, hey, these are good service candidates, something that we can organize our software around, because it makes it easier to categorize and work incrementally if you can organize your software around particular capabilities or particular functionality. And this is leading into the next step. Then we have our ubiquitous language, we have an idea about what the system does, and now we're starting to see how the system actually is organized from a capability perspective. And then we move on to the next piece where we're starting to think about thin slices. Next, we want to start understanding the interaction between these capabilities. And we are wanting to think about situations that may happen in today's business that are painful with the software, or we just want to make sure that this particular use case or journey through the system from a user perspective makes sense, or from a system to system perspective. And we use thin slices as a way of thinking through a very specific use case. How are we going to model this? How do those service candidates that we discovered, how do they interact? And so the next step of Swift is doing just that, thinking about what are the types of scenarios that we want to be able to model. We want to be able to look at good cases, bad cases. We want to make sure we have the same functionality parity that we do today, but we also want to make sure that everybody involved gets to put in their information, right? They need to think from their perspective. A complex system has a lot of different views and lenses, and then we can prioritize that and think about, okay, if we're going to model each of these thin slices, what's the first one that we should do? Now that we have an idea of what thin slices we want to use to exercise our model, we can start modeling that. That process is called Boris. And when we're walking through Boris, what we're really doing is taking a thin slice and saying, hey, we have this empty canvas with just our service candidates. Let's walk through and try to understand how things work. But we're also going to do it in such a way that we can avoid common issues that we see, right? Like in the case of big complex distributed systems, there's often situations where things like large messages or orchestration or vulnerabilities, we're able to play the what if game and make sure that not only do we achieve the goals of the business from a thin slice perspective, that the notional architecture that evolves out of this is best suited to take advantage of the modern platforms and the modern technologies that we have today. So really what we're doing is looking at criteria like, is this a microservice? Should this be a microservice? But the end result is a fairly simple model of the business itself. But this model is what is going to be generating the software itself. So this is the map that shows how we get from point A to point B. And not only how we get there, but it gives us the assurance that as we're going, we're taking advantage of the resources that we have available, and that we're also not going down the path that we went down before that caused us to be here in the first place. So as we're going through and modeling this, we're drawing a lot of lines, we're talking through things. This is really a collaborative effort. And the result of the Boris is not the diagram. The outcome is really the consensus that, yes, this looks like a good direction forward. The model, the output that you see is really just the result of those discussions. And of course, as we're doing this work in Boris, as we're modeling, we're drawing lines from point A to point B. What that's really telling us is there's APIs that need to be exposed. We're talking about the data that capability should be responsible for. And we have a need to store that information that we're gathering, but not get in the way of the modeling. So while we're doing Boris, while we're walking through, asking these stupid questions, really trying to understand from a thin slice to a thin slice, does our system hold water? Does it work the way it's supposed to? We're generating a lot of information that we're capturing in detail, kind of in shorthand, organized by each of those capabilities. What are the data responsibility? What are APIs that are supposed to be exposed? Are they publishing events, subscribing to events? What kind of business logic really needs to be part of that particular capability from a compliance perspective or from any other type of logic? And this is the result that we'll have from this exercise is we're able to see what really needs to be built, which is going to feed into the next step. So after Boris and Snappy, we know generally how the system wants to behave. We have a notional direction or a notional architecture that seems to make sense, that's been solidified, validated, tested. We've thrown rocks at it, but we need to start thinking about how are we going to build this. And thankfully, there's a lot of patterns that come up, both from doing Boris, where we see repetitions within the business on how things work, but also there's design patterns and there's modernization patterns that we can start applying to the model that we created. So we look at this point where you are today and where you want to be in the future, and here's some techniques that have been used in the past to get you there, or here's some processes or designs that make sense. And having these patterns is what makes it possible for us to then start doing the work, start thinking about the backlog itself. What work are we going to be doing? And from these patterns in this direction that we have, it's easy to feed that into a backlog of work, something that is stories, or if you're using different techniques, this is essentially the stuff that needs to be done, the templates that need to be built, the coding that needs to happen. And once we have that, we're able to start doing the coding. And of course, this is iterative. If we discover more information, we simply go back to our model and say, hey, we discovered something new. Can we handle that? Can we do something with it? Can we start building, and make changes? But ideally, if the software modeling worked the way it's supposed to, those subtle changes and things you learn are going to have incremental effects, very small risk to build that. So part of our model that we're looking at, that notional architecture, is not just software, it's also the way the software is deployed, the CI/CD process, the DevOps, all the buzzwords. But really, a modern system is a combination of the software that supports the business, the data that each individual component or each individual capability is responsible for, coupled with the process to get to the infrastructure where that software is going to be run. And then finally, that infrastructure is tuned to the needs of the software. And that process of DevOps is continuous all through this process. So once we go through the Swift exercises, we finish our coding, we're going to be able to rapidly deploy and reap the values of the work that we did over just 3 short weeks, for example, to get from we have no idea how the system wants to behave in the first place to we not only have an exercised, validated model of what the software should look like, but we're actually implementing. We're doing the work. It's getting out there. We have a happy cloud environment, and we're starting down the modernization process. And a happy cloud environment means a happy system, a well-structured, modern system of applications, an application group that works well together, takes advantage of the benefits that you get by modern platforms and modern technologies, and you have a pathway to get from that point A where you are with your legacy systems to the advantages that you get from the modern techniques that we discovered as we were going through this Swift process.